Hi friends, welcome to this class. So in last class we discussed about the structures, 3D view, 2D view of silicates, right? So general formula we have seen, and we discussed the structure of this orthosilicate and pyrosilicate, right? So let us see in this class, let us see the classification of these silicates, right? So we classify these silicates into these four. So one is orthosilicate, pyrosilicate, cyclic silicates are there, and chain silicates are also there, right? So let us see what all those things, how they look, what their structure, everything we shall see, right? So this orthosilicate is also called by another name, that is nesosilicate. Just you write nesosilicate. And this pyrosilicate is also called by the name sorosilicate, right? So this is other names, so you should know that. And the examples, those things that I will tell them later, right? So once again let us see one by one. So what is this orthosilicate or nesosilicates? So I have told this orthosilicate or nesosilicate will have the formula like this: SiO4 4 minus 1 minus 2 minus 3 minus and 4 minus SiO4 4 minus, right? So this is the structure of orthosilicate, right? So in two-dimensional view we saw that silicon we represent by a dot, and one oxygen will cover that silicon and other oxygens will be like this: one oxygen, two oxygen, three oxygen, and this fourth oxygen, and each oxygen carries negative charge, right? And there will be like this, they will show like this in textbook, but it doesn't mean there is no OO bond, there is no oxygen bond, only 4 SiO bonds will be there, 4 SiO bond, like this SiO bonds. This silicon oxygen bond, this silicon, this oxygen, silicon oxygen, silicon oxygen, right? So that also we saw with this model, right? So this is the silicon, this above oxygen is there, right? So this above oxygen is covering this silicon. So this silicon I have shown it by dot, oxygen with a round circle above it, so it means like that. And other three oxygen, 1 2 3, it will look like this. So this is two-dimension view of orthosilicate, right? So pyrosilicate or the sorosilicate. So what I have told, two molecules of orthosilicate, if they combine, we will get like this: Si, 1 oxygen, 2 oxygen, 3 oxygen, and 4th oxygen. This 4th oxygen is there, right? That is common to one more unit of this, like this, right? So here, since this oxygen is satisfied, that is octet rule it has satisfied, one oxygen can have only 2 bonds, so there is no negative charge. Since here this one oxygen having only 1 bonds, so they will be having negative charge like this. So if you see the formula, it will be like Si2O7, 1 2 3 4 5 6 7, O7, 3 minus here, 3 minus here, so 6 minus, right? So if we want to see this 2D view, how we can show? So this is my silicon, above 1 oxygen is covered, right? So 1 oxygen here, 1 oxygen here, 1 oxygen here. So we can show like this as they have given in the textbook, right? So this oxygen is there, that is common to one more unit. So this is the oxygen which is common to attach to one silicon, and that silicon attached to one oxygen which is above, and other 2 oxygens like this, right? Right, so it will be like this two-dimension view. But here it means only SiO bonds are there, no oxygen bond. In exams they may ask how many oxygens will be shared in pyrosilicates. You should tell only 1 oxygen, only this oxygen is there, right? That will be shared with this unit and this unit, this silicon and this silicon. See here, this oxygen is shared with this silicon and this silicon. That is the important thing you should know, right? So this is about pyrosilicate, right? So here you may feel so many bonds. These are not bonds, these are simply representation, how they will represent in books, that I have shown you. This is 2D representation, these are not the bonds. I have told you there is no O bond, only SiO bond. This is the bond and this is the bond, other these things are there, right? So this is nothing but simply representation. Here you can see only this SiO bonds are there, 2 two bonds, only two bonds are there. You may ask, sir, how these bonds are there, 1 2 3 4 5 6 to the single oxygen. These are not the bonds, right? Simple representation. So this is about pyrosilicate or sorosilicate, right? And you may ask, sir, give examples for this. That thing I will make other videos in which I will explain some English which you record and a few examples to remember and write it in the exam, right? So these things, that things I will explain later, right? Some other videos I will make so that you should know little English also. Some sentences you will get there, right? So cyclic silicates, what are these cyclic silicates? So cyclic silicates are nothing but silicates will be having some cyclic structure. For example, see here, silicon, orthosilicate only, you should remember only orthosilicate. 1 oxygen, 2 oxygen, 3 oxygen, the 4th oxygen I will show like this above. So if I want to show that 2-dimensional structure, I should show this silicon with a dot, and the above oxygen that covers that silicon, like that I should show, right? So this is the orthosilicate, right? And 4 minus, now I am not going to put that because I want to continue. This oxygen is shared with one more silicon. Silicon I should show with dot, right? And that silicon will be having 4 oxygen, right? 1 oxygen, this 2 oxygen and 3 oxygen, and this one is the 4th oxygen, right? Similarly, this oxygen is shared by one more silicon. So this is silicon, and this silicon will we should have 4 oxygens, right? So 1 oxygen, and this is 2nd oxygen, 3rd oxygen, and this oxygen is again shared with this silicon only. So if you see, this is cyclic structure, right? So here you can see this oxygen is bonded to 2 silicons, so no negative charge. Here also this oxygen bonded to 2 silicons, no negative. Here also bonded to 2 silicons, no negative. So only these oxygens will get negative charge, right? So if you see how many silicons are there, I have told silicon I will represent by dot, oxygen I will represent by circle. So how many silicons? 1 2 3. So if you see the formula, Si3, oxygen you count 1 2 3 4 5 6 7 8 9. Si3O9, 3 minus. So this is nothing but the formula of this cyclic silicate. If you see, it will show us like it is cyclic in structure. I have not done nicely. If you draw it nicely, you will get a cyclohexane like structure like this. You will get nicely. You will get just to draw it nicely, right? So for this cyclic silicate, we will have one general formula. It will be like Si, right? O3, SiO3 N, and here it will be, right, SiO3N. Yeah, that will be the formula, and above it will be having 3 minus like this only, I think, right? So if 3 silicons means here N is nothing but 3. If 6, what we will get? We will get one formula. That structure let me draw. See here. So the one more structure, and other thing, this I have not completed, right? Negative charge here. Sorry. What the thing I have missed? This oxygen is there. The silicon above which one oxygen is there, right? So this silicon above which oxygen, that will also having negative charge. So here negative charge, here negative charge, here negative charge. So it is not Si3O9 3 minus, it is 6 minus, right? So general formula will be 2N like this, right? So if it is 3, what I will get? Si3, 3 3s are 9, O9, and 3 2s are 6, minus 6, right? So this is the formula of this molecule, right? So if instead of N I will take 3, if I take 6, then what I will get? It will be Si6, 3 into 6, O18, 18 it will be, right? And totally how much? 6 into 2 minus 12. The structure I should draw it. How I will draw? Just see. Oxygen, see here, nicely I will draw oxygen, right? so that let me maintain the symmetry. Oxygen, 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 right? So this is oxygen. So here I will show silicon like this. With the dot I will show silicon here, everywhere. These are silicon. How many silicons? 6 silicons, because Si6 silicon. These are the silicons I have drawn, right? So these are attached to these oxygens, no doubt. This is silicon oxygen bond. This is 2-dimensional view, right? So what I did, first I drew 6 silicon in hexagon structure, then silicon, 6 silicon I have shown. Other oxygen, one oxygen will be above the silicon like this, right, above this silicon, right? And other totally SiO4, right? SiO4 4 minus ortho silicate, 4 oxygens will be there, 1 oxygen, 2 oxygen, 3 oxygen, and other oxygen will be like this. Everywhere you should draw like this, right? And the negative charge, these oxygens will get negative charge as they are having only one single bond, right? And this oxygen also only silicon oxygen single bond is there, so negative charge here, right? And these oxygens are shared with 2 silicons, 1 bond, 2 bond. So 2 bond means oxygen with 2 bonds, no negative charge. Here also no negative, no negative, no negative. Now you count. Si, how many silicons are there? Dot 1, 2, 3, 4, 5, 6. So it is Si 6. How many oxygens? You just count. From here I will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right? 18. Oh, 18. I am getting oxygen 18 is there. Negative charge 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Minus 12. Negative charge. So same formula we got. So general formula for this this ring also, it is SiO3 like this. It is the general formula, SiO3 minus 2n, here n. So n represent the number of silicons. If number of silicons is 3, I will get this structure, and the formula will be like this. If number of silicons are 6, then I will get this formula, and the structure will be this thing like this. You should know. And I have not completed the structure. How we will complete that structure? I have told in book what they will give. They will give like this. So this is the completion of this structure, right? Like this. I hope now it's clear to you. In books, if you directly see, you will get surprised, sir, how to remember all the structure. It is so complicated, right? But see how easily I did it. Now I am making it complicated. So this is how it looks. This is how they will give in the textbooks, right? So this is 2-dimensional view. Similarly here you can do the same. This oxygen bond is not there, but in textbook they will show it like this. It means it is 2-dimensional picture they are showing, right? But it doesn't mean no O bond, right? Means there is no oxygen bond. Only to show 2-dimension they will show it like this, right? So this is the structure. This is how you should remember. I hope you got how to draw. If you feel you haven't got it, just rewind the video and again you watch it. So this is the story of cyclic silicates, right? Because they will form a cyclic ring-like structure. So their structure will be like that, right? Now let us discuss about this chain silicate. So chain means it will be having like this chain. In this chain silicate, there will be 2 kind. One is simple chain like structure, which I will draw now, and the next comes the sheet like structure. Sheet. In lab you can see, in lab is there, right? So in chemistry lab you can see it contains a very black color like sheets will be there, right? Black color, like on table there will be black color rock sheet. That is nothing but asbestos sheet we call. Asbestos sheet. These are nothing but this chain silicates only. this chain silicates, that is asbestos sheet is the good example for this sheet like chain silicates, right? So good example. These are black, these are rocks only, I guess. These are rocks, because silicates are nothing but rocks. So in lab we will be having, right? So in which they will keep all these items, table they will make, and this black color, this much big very heavy sheet will be there, right? Black color, which is made up of rock, that is nothing but asbestos sheet. About its structure now we are going to see it, right? So chain silicates. So here same orthosilicate, if you remember, one oxygen here, second oxygen, one silicon, above which one more oxygen, one more oxygen. 4 oxygens are there, right? 1, 2, 3, 4, right? And one silicon, right? And there will be bond like this. For all oxygen silicon bonds will be there. And this oxygen is again shared by one more silicon here, like this. And here oxygen will be there, above one oxygen and oxygen like this, right? And again this oxygen is shared by one more silicon. And here I will have oxygen, above one oxygen, and here one oxygen, like this. And this oxygen is again shared by one more silicon, and here oxygen, and here oxygen, and above one oxygen, right? Like this it will keep on going, right? So here oxygen, and again continue. Here oxygen, again it is continued. So like this you will get a straight chain. So such kind of silicates we call it as chain silicate. And also see, in orthosilicate no oxygen is shared, no oxygen is shared. But here in pyrosilicate we saw only one oxygen is shared. See here, SiO, this oxygen is shared with one more unit, like this. In cyclic silicate what we saw, I forgot to tell, there 2 oxygens are shared, like this. Oxygen, one oxygen, 2 oxygen, one above oxygen will be there. This oxygen is also shared with silicon, this oxygen is also shared with silicon, right? So silicon we show by dot, but here I am showing like this because I have explained you all those things, right? So 4 oxygen, 1, 2, 3, 4, here also 1, 2, 3, 4, here also 1, 2, 3, 4, right? So here if you see, from one unit 2 oxygens are shared, this oxygen are shared. And here also you can see, right, 2 oxygens, 1 oxygen and 2 oxygen, like this. Here 2 oxygens are shared. In pyrosilicate 1 oxygen is shared, in orthosilicate no oxygen is shared. And here also you can see, here 2 oxygens are shared. This oxygen is also shared, and this oxygen is also shared. For this silicon, this oxygen and this oxygen, both 2 oxygens are shared, right? So we will get sheet like structure. If and just to connect like this, so it will look like this, right? So it will form like this. So this is nothing but my chain silicate, in which silicon will be here, oxygen, 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 right? Silicon will be here, oxygen, oxygen, oxygen. 4 oxygen, 1, 2, 3, 4, 1, 2, 3, 4, 1 silicon, 1 silicon. Here also 1 silicon, 1 oxygen, 2 oxygen, 3 oxygen, and 4th oxygen, right? And if you want to see the number, right, and you know that if this oxygen is shared, so it won't get negative charge. This oxygen is also shared, it also won't get negative charge, but this oxygen gets negative charge. And this oxygen above the silicon will also get negative charge. Here also negative charge, here also negative charge, here also negative, 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 and negative. And this oxygen is again shared. So like this chain we will get, right? So this is nothing but my cyclic silicates, right? So this is how you should see. So this is how this is how they will give in books, right? So negative charge they may not show, totally they may give, like that also it will happen. So you should know how to draw, right? So this is how you should draw: oxygen, 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 and here you should draw like this: oxygen, oxygen, like this. So this is nothing but 2-dimensional view. This is about chain silicates, right? Chain silicate. Now let us see this sheet silicate, that is asbestos sheets will be there, right? How it will be, right? So here also in chain silicate you saw that 2 oxygens are attached. Since here till for this, if you see only 4 silicons are there, I can give the formula like Si4. Oh, how many oxygens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 12, 13. O13 negative charge 2, 4, 6, 8. 8 minus, but the chain is not stopped. Here also it is there, here also it is there, right? So the formula will keep on changing, but for this I can give you the formula like this. General formula, if I get that, I will tell you in next class, right? So orthosilicate, no oxygen is shared. Pyrosilicate, one oxygen is shared. In cyclic silicates, 2 oxygens are shared, whereas in chain silicates again 2 oxygens are shared. These things you should remember. In some exams they will directly ask, in pyrosilicates how many oxygens are shared. Just you should tell 1 oxygen, right? So now let us see about this sheet silicates, that is asbestos. Similarly, what this is silicon, above 1 oxygen, here 1 oxygen is there, and here 1 oxygen, here 1 oxygen, right? Again, just to make a line like chain silicate, from this oxygen is shared to 1 more silicon, and here 1 more oxygen is there, and above 1 oxygen, and it is attached to 1 more oxygen like this. Again, this oxygen is shared to 1 more silicon, to this 1 oxygen, 2 oxygen, this is 3rd oxygen, and 4th oxygen is above the silicon, right? So this you know, because you just now only you studied the chain silicate. My aim is how you will remember how to draw, that I am explaining here, right? So this is the structure, right? Negative charge, those things we shall do it later, right? So this is the structure. Again, here 1 more silicon, 1 oxygen, 2 oxygen, and 4 oxygen, 1, 2, 3, 4 oxygen, right? What happens? This oxygen is there, right? That oxygen again shared with the silicon. So 1 oxygen, 2 oxygen, 3 oxygen, 4th oxygen. Again it will form a chain here like this. So here this oxygen is again shared with 1 more silicon. So 1 oxygen, 2 oxygen, 3 oxygen, and 4 oxygen, right? So this oxygen is again shared with 1 more silicon, and here 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen, right? And here similarly here also the same thing happens, right? Oxygen, oxygen, and oxygen like this, right? Sorry, here also I should get silicon here, right? Silicon here shared with oxygen, here oxygen, and this oxygen, right? So this is how it will happen, right? Here silicon, oxygen, oxygen, and oxygen. So 4, 1, 2, 3, 4 oxygen, 1 silicon, 1, 2, 3, 4 oxygen, and 1 silicon, 1, 2, 3, 4, and 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 silicon. So you can see here 1 chain silicate, here 1 chain silicate, both are linked through oxygen, right? If you see the sharing, here this oxygen is again shared, and here this oxygen is again shared, right? If you see here the common connection, 3 oxygens will be shared, 1 oxygen, 2 oxygen, and this one, 2 oxygens are shared from each unit, right? But here this linkage is also there because of, see, if you see for this silicon, 3 oxygens are there, 1, 2, 3, and 4 oxygen, in which 3 oxygens will be shared, right? So here no oxygen is shared, so it is 0 oxygen shared. Here in pyrosilicate or sorosilicate, 1 oxygen is shared. In cyclic silicates, we got 2 oxygens are shared. In chain silicate we will get 2 oxygens are shared. But in sheet silicates like this, there will be 3 oxygens will be shared. I have told 1, 2, 3 oxygens are shared, right? So how it will happen? So if it is the simple chain silicate, in sheet silicate 2 chain silicates will be there, right? So there will be some oxygen linkage like this. So this bond, again there will be 1 more chain like this, and here again this linkage will be there. So like this it will form, because of this linkage, the number of chain silicate combined together to form this sheet silicate. So this sheet which we will see in lab will be very strong, very heavy. Why that is? Because so many number of silicates, this chain silicates have combined to form this sheet silicate. So these are very strong and heavy, right? So this is the structure, right? Again what I have told, just you have to combine like this, right? These things you know, because we have studied this, right? So how 4 oxygen and 1 silicon, means 1 unit like this. So 4 oxygen, 1 2 3 4, and 1 silicon is there. 1 2 3 4 and 1 silicon like this. Similarly above also you can combine. So like this you will see in lab, in textbooks, right? So this is the structure. I hope you got it nicely, right? So orthosilicate, right? So this is the sheet silicates, right? So this is the structure. About the structure of all those things we have studied. So orthosilicate, you can show it like this, right? Pyrosilicate means 1 oxygen, 2 oxygen, 3 oxygen, that will be shared by 1 more. Here silicon will be there. So 4 oxygen. This one unit, and there is linkage, right? So this is pyrosilicate. In cyclic silicate, what we did, we got this silicon and oxygen, silicon and oxygen, and other oxygens will be on silicon only, right? And this was the structure. So 4 oxygen, 1 silicon, 1 unit, 4 oxygen, 1 silicon, 1 unit. So this is the structure of cyclic silicates. Similarly chain silicate also we have discussed. I have about 3 more minutes, let me show them. So chain silicate will be like this, correct now? Yes. So here silicon oxygen will be there, everywhere oxygen, silicon oxygen, everywhere oxygen, silicon oxygen, everywhere oxygen, like this. So you can show this linkage also. So this is nothing but my chain silicates, in which 2 oxygens are shared. In sheet silicates what happens, 1 more chain will come, in which this oxygen again shared with silicon, oxygen, oxygen, right? So 1 unit like this. So here 1 more chain will come, in which this oxygen is there, right? So this oxygen again shared with this silicon and 2 oxygen here, right? So further here 1 silicon and linked to this, and 1 oxygen here, second one, like this. They will form a sheet like structure, in which in sheet 3 oxygens are shared. In cyclic structure only 2 oxygens, 1 oxygen and 2 oxygen from 1 unit is shared, so 2 oxygens are shared. In pyrosilicate only 1 oxygen is shared, you can see that. In orthosilicate 0 oxygens are shared. And negative charge I have told, negative, 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 negative. If oxygen is bonded by 2 bonds, then no negative charge. If oxygen is bonded by only 1 bond, then there will be negative charge. That I have explained it, alright. For example, with pyrosilicate only you can take. These oxygens are there, right? This oxygen is bonded to 1 more silicate. So since it is bonded to 2 silicate, it has got no charge. But these are bonded to only 1 bond, so negative charge you will get, right? So this is how. So general formula, structure, everything we have discussed. Only thing is, let me give the examples of all these things and some little English if required, that I will explain in next class. Till then, take care and have a great day.